Okay, so this today's topic still on matrices. Okay, you should be able to do these things on the screen. So look up, check that you are able to do this, otherwise you cannot follow today's lesson. You know how to display information in the form of matrix, from a table to a matrix? Can identify the order in the matrix? Can. How many 2 by 3, 4 by 8, whatever it is. Interpret the data in the matrix. You know all the elements they represent something. Addition and subtraction. That's about where possible. When is it that we cannot add or subtract matrices? When the orders are different. Okay. Then can you do scalar multiplication? It's just a number multiplied by all the elements inside. Okay, next. Today is our matrix multiplication. So this is an introduction to what it is about. We had this information, November 15. I think this was the first table that was given to you, right? Okay, then numbers represented in a matrix. Then selling price and the profit. Do you know the difference? Selling price? So the price tag, when you go and buy something, the price tag shows the selling price. And when he collects, when the seller sells you the phone, he gets a certain amount of money. So when you add up all the money that he gets, it is called the revenue. And profit is simply the amount that he makes after you take the revenue minus the cost price, whatever price there are. Okay, so that's the profit. So here we have another matrix. Are the orders the same? These two matrices, do they have the same order? No. Yes or no? Different, right? The first one is 2 by 3. Second matrix will be 3 by 2. But is there a relationship between these two matrices? What is common to both of these matrices? Okay, first one iPhone 6s, then? So you're telling me the handphone models are the same? Right? Handphone models are the same in the first matrix, and the rows, they have iPhone 6s, S6 and Note. And then in the second matrix, P, in this column on the left, we see the same iPhone 6s, S6 and the Note in the same order. Okay? First one, second, third. First, second, third. Okay? That is one thing you need to know. It is very important. Next. I asked you to calculate the revenue of all the phones sold in Bedok. So revenue means all the selling price multiplied by the number of phones sold, add them all up. Okay? So without all this information, do you think you can find, or rather tell me how to calculate the amount of money he collects in Bedok for this one? How much money does he collect? What times what? 45 times 850, is that all? Plus 30 times 800 plus 34 times 350. That is the amount of money he gets in Bedok, right? For the month. Then what about, let's say I want his profit. How much is the profit made in this month in Bedok? How do we get a profit then for Bedok? What times what? 45 times 100, is that all? Plus 30 times 350 plus 34 times 50. Are you all following? Are you all really all okay with it? Because I only hear Sophia and Junior answering me. So are you all really okay with the calculation? Okay. Do you realize that for both calculation, it is always something times something plus something times something plus something times something? It's very repetitive, right? Okay. And we actually have that for the other two elements also, for C main. Okay, so total revenue. Okay, I've got these two matrices. To find the information in this box, so I think it will be in your table given to you on your second page. I would like you to write these things down. For the total revenue, what are we going to fill in? First row, this is my first row, first column. The answer is found in the first row for the first matrix, multiplied by the first column in the second matrix. Can you see the pattern? Okay, one more time. In my answer, first row, first column, the answer is found in the first row of the first matrix and first column of the second matrix. We are going to multiply these numbers up, which is what you did as part of your homework. Okay, so 45 plus 850, 30, 800, 34, 350, 74150. For those who have done it already, check that you have the same value. And I want the working, because you are supposed to learn something from this. Anybody managed to get 74,150 without me showing you the answer? 35, do you get a value? Okay. So next, what about the profit? Profit is found in which row, which column? First row, second column. So where do you think the answer will lie from the two matrices? First row of the first matrix. Okay, so now we move there. I want the first row, second column now. So the answer is found in the first row of the first matrix, then multiply by the second row, second column in the second matrix. You get it? Okay, so we're going to fill out the blanks. And we see that these values, 45 is found here, 100 is found in the second column in the second matrix, and everything else you get 16,700. So if you got the first one correct, you should get the second one correct. And which means you should get everything else correct. Okay, go and practice writing down all this multiplication and addition. It is important for you to be very familiar with it. Very simple stuff. Just add and multiply. Primary school kid also can do. But you must know what to multiply by what to add to what. Okay, so now let us move down to C main. It is found in the second row, first column. So second row of the first matrix. Move down to the second row, and we move back to the first column of the second matrix. We're going to multiply these values together, we're going to add them up. And this is what we have. I'm sure you can do the last one by yourself. Second row, second column. Multiply them, 9,800. So you see, after you multiply, you get another table. So the information in this table can be translated into a matrix again. So this is my matrix U, just a random letter. And it contains 74,150, 16,100, 45,050, 9,800. Are you all okay with the headings in the last table? Is the heading all correct? Total revenue, total profit, total and CMake? Alright? Okay. What do you notice about the headings of the original two tables? Something disappeared. Originally, in my two matrices, I've got the outlets, I've got the models. In the second matrix, I have the models, I have the prices. When I multiply these two together, something disappeared. What disappeared? The place? No, you see, my final table, I still got Bedok and CMake. So what disappeared? The handphone model. Yeah, when you multiply two matrices together, a piece of information will disappear. In this case, in my final table, I lost all the information about the handphone models, right? And we notice that actually that is what ties your original two matrices together. The original two matrices, they had something in common. That is the handful model, right? After you multiply that, it disappears. What we have left will be a summary, sort of a summary, where we have part of the information. This over here, Bedok and Simei, it came from our first matrix. Then we've got the revenue and the profit. It came from the other matrix over there. It's like a combination, but you lose some information. That is the handful models. Okay? So this is what matrix multiplication is like. So, in summary, when you are given matrix multiplied by matrix, you get another matrix. Okay? And it looks like this. N, matrix N times matrix P. Multiplied together gives you another matrix. Without the context, without the story over here, you are expected to be able to do this. Matrix times matrix. This first number must be 45 times 350 plus 30, 800, 34 times 350. Add them all up, I get this number. Second number, this row multiplied by this column. For this element, second row, first column. For this element, second row, second column. You are expected to be able to do that without a story given to you. Okay? So there is some memory work that you have to do. That is, you must know how to get all these numbers. Can? Okay, next thing. So this is a matrix multiplied by matrix now. Okay, so this is found in your textbook page 78. This is the definition. Do you think you can understand it? Can you understand? Try. If A is the matrix order m by n, B is matrix order n by p, product AB is for the multiplication of two matrices A and B. It's a matrix order m times p, element in the I row, j column, blah 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 blah. Not easy to understand. Is it correct? Oh, sorry, I got a page wrong. That means I didn't save it. It is found in page 134. Page 134, refer to it. Textbook page 134. Well, all the n by n, n by p, I row, j column, so much. Okay, I'm going to use our example, the one that you did it by yourself, to interpret this. We had U equals to matrix n times matrix p, right? We did the sales in November and the prices and the revenue in matrix P. So these are the two matrices that are multiplying. Okay, matrix times matrix. In this case, what is my matrix A? See, according to the definition, there is a matrix A, right? Which one is A? The first one, the first matrix is A. Then matrix B will be P. Okay, my second matrix. The order matters. Whether it is n times p or p times n, there is a difference. And you must be very clear. What multiplied by what? Okay, so now, matrix n. The order, 2 by 3. Do you agree with this? The first matrix, 2 by 3? Yes. Okay, matrix B is now changed to matrix P. What is the order? 3 by 2. Then the product, which is NP, is a matrix of order 2 by 2. How do we get this 2 by 2? Okay, based on the definition, this first number, this 2 over here came from this 2. This second 2 came from this 2. Okay. And take note, for these two matrices when multiplied together, this n, this value must be the same as this value. Then we can multiply. Look, it is n by n. The other matrix must be n by p. These two n must be the same before you can multiply. And the resulting matrix will have order of n by p over here, n by p. Okay, so replacing them with numbers, we get 2 by 2. Okay? And they say the element in the I row. Okay, let's talk about, okay, so this is what we have, I row. Let's talk about the first row. And there we have it, the first row. Since I know it is a 2 by 2 matrix, I can write it down. I just need to find out what is this x11, x12, x21, x22. Okay, so first row, first column. This is my first row, first column. I'm talking about this one. It is found by the sum of the products of the corresponding elements in the I row. I row of A is the first row of A over here. Okay, sum of the products of the corresponding in the first row and the first column of B over here. This is what I was trying to tell you. Basically, all those words is saying that this element over here is found by this multiplied by this and they're all products. Get it? Okay? So it's very hard to memorize what it means. That's why when you practice, just keep multiplying, adding, you will eventually know what to multiply, what to add for which element. Okay, so first element, the first row, first column will be given by 45 plus blah blah blah. And for the second element over here, the first row, second column. So first row, second column. So we call it X. First row, second column, X12. It's just a name, okay? You don't need to know the names, you just need to know what multiplied by what goes where. Okay? So the next element, which I want is 2, 1, is found by second row, first column. So you see we have all this information. And the last one, second row, second column. So second row, second column. Add them up. And we have the values to place inside my matrix. Okay, 4 numbers. Anybody lost? Am I clear? Then you practice yourself. What if the number of rows in N is not equal to the columns in P? So what do I mean by that? Let's say this N over here is different from this value over here. Let's pretend they are different. Because right now they are the same. So 45 has a partner, it is 850. 30 as a partner, it is 800. 34 as a partner, it is 350. What if the number of rows in the first matrix is different from the number of columns in the second matrix? So let's say we have something like this. Okay, so I've got 2 matrices. And what is the order for matrix N in this case? U equals to N P. So this N over here, the order is 2 by 3. This one will be 2 by 2. Okay, so we see that this value and this value, they are not the same. Don't care. I try to multiply again. Let's see what happens. So according to the definition, I'm going to take to find the first element. First row, first column, right? I'm going to take the first row, multiply by the first column. Okay. Okay, now, this is going to be given by 45 times 850, okay, plus 30 times 800, 30 times 800, then 34 how? 34 got partner? No partner. Cannot multiply. So, it doesn't work. You cannot do a multiplication if these two numbers are different. Understand? Okay, so that's all for this portion. I want to now show you on the screen what are some matrices that you can multiply and some that you cannot. Okay, then you just tell me whether can or cannot. Okay, A equals to B multiplied by C. Okay, they're all matrices, but B has order 2 by 8. And C, okay, I should write it this way, okay? And C, order 2 by 8. And the other one will be 8 by 3. Can or cannot? Can or cannot? Can. Okay, result. I really hate the starter sometimes. Result of A, which is the order will be 2 by 3. You get where the 2 and the 3 come from? Okay, let's try another one. What if B is now 3 by 2 and 3 by 3? Can or cannot? Can or cannot? So we just look at this number and this number. Are they the same? Not the same, so cannot. And A. Okay? What do you mean? Oh, they won't test you that. I'm just telling you have to realize when it works and when it doesn't work. Okay, maybe another one, another few more. 4 by 6 and 6 by 1. Can or cannot? Can. Okay, what is the final order? 4 by 1. Easy? Okay, now we go back to our textbook. Multiplication of matrices. This is what I was telling you about. So we have two matrices, A and B. What is the order for A? Order for A? 2 by 3. Here order? 3 by 2. Can multiply or not? Can. This 3 and this 3 are the same. Okay, put them together. For my first element, over here, this first element, 422, it is found by taking the first row of the first matrix, multiplied by the first column of the second matrix. Multiply them together, you get 422. Okay, so this diagram describes exactly what I was saying. So just add everything up, multiply, and we get this. Now in matrix multiplication, I would like you to write down this information in the final matrix. Okay, these are the headers. Because matrices, they have meaning. And let us, earlier in my slides, I showed you, right? Some information was missing after I multiplied. The Hanford model disappeared, but some information remained. For example, the store, location of store, Bedok and Simei, they remain. They came from my first matrix. Then the prices, the amounts of money, it remained. The header remained. Came from my second matrix. So if you look at this example, okay, this example over here, what is something that is common between these two matrices? Look at the context. What is similar between these two? Subjects. I've got English over here. I've got English over here. I've got bio, physics. When you multiply them together, what do you think will disappear? Yeah, these subjects will disappear. All these will disappear. What then am I left with? Store 1, store 2, price and mass. Okay? And take note, your resulting matrix will be 2 by 2. 2 rows and 2 columns. Corresponding to 2 columns, 2 rows over here and 2 columns. Okay? They are corresponding. Price and mass, found over here. Price and mass. Then store 1, store 2, found in my first matrix. Okay? This is the key to answering the final question of matrix, which will be interpret the result. You will need to use this information to answer that last 1 mark question. Always will come out. Okay. Practice. Example 14. We start with a simple one. 2 by 2 and 2 by 2. Multiply them together, what do you get? You've got an example over here. This is the presentation. Okay? Add them all up properly. I prefer to, instead of 2 times 3 plus 5 times 0, right? I would have written it this way. So my answer, 2 times 3 plus 5 times 0. I will use brackets for my multiplication because it is neater. Then in the first row, second column, I've got 2 times of negative 4 plus 5 times of negative 8. Okay, then I continue with the rest. I prefer it this way because it is neater as compared to writing all these multiplication signs. But the answer will still be the same. So your turn now is to try it 14. Part A and part B. You have 5 minutes for this. Until 1:06. Right, so this is part A, and I'll erase this and start on part B. Q times P. Part B. So write down the matrix for Q: 6, -1, -9, 0, 8, 2. Multiply by 1, 3, 7, and -2, 5, -4. Let's check. Is this a valid multiplication? Valid, right? This is actually 3 by 2. This is 2 by 3. Okay, these two numbers are the same, and I'll expect to end up with a matrix of 3 by 3. Okay, so it's going to be a very big matrix now. Okay, so first row, first column. Multiply them together. 6 times, okay, 1 plus 0 times -2. That's the first row, first column. So now I want to move on to the first row, second column. What do we have? 6 times 3 plus 0 times 5. Move on to the first row, third column. And that will be 6 times 7 plus 0 times -4. Okay, so you see now I have 3 columns already. And I'm expecting 2 more rows, because eventually it's going to be 3 by 3. So remove this. Okay, so now moving on to the second row, first column. -1 multiplied by 1 plus 8 multiplied by -2. Then second row, second column. I've got -1 multiplied by 3 plus 8 multiplied by 5. Now second row, with the third column, giving me -1 times 7 plus 8 times of -4. Now the last row, and first column. So -9 times 1 plus 2 times of -2. Now for the second column, 3 and 5. -9 times 3 plus 2 times 5. And the last one, -9 and 7 plus 2 times of -4. Okay, done. And I want to check just by looking. Can you see that some numbers are the same? All the ones here. -2, -2, -2, 3, 3, 3, 5, 5, 5, 7, 7, 7, -4, -4, -4. Okay, I'm sure I didn't make any mistake over there. So the next one, let us look at. I'm not recording? Yeah, I am. Yeah, I'm recording. So next one, we look at this 6 over here. 6, 6, 6, 0, 0, 0, -1, -1, -1, 8, 8, 8, -9, -9, -9, 2, 2, and 2. Work it out with your calculator. Okay, so 6. Because there's a 0, I love to see multiplication by zeros. Then I've got 18. And over here we've got 42. Then -1 times plus -16. -17. How much? 37. And the last one? -39. Okay, last row. How much? 1, 3. Okay, then. Okay, last one. 71. Okay. Can? Do you all get this? Okay, so we will do. One thing to note: PQ and QP, are they the same? No, right? The order is different already. They cannot be the same. Okay. Okay, now over here I've got some things to introduce to you. This C over here is known as the null matrix. Yes, NULL matrix. Then this one over here is called this I over here is known as the identity. IDENTITY matrix. Do we need to know the name? No, you don't have to know the name. Just know that this identity matrix has a lot of zeros, and there will be a diagonal over here that has ones in them. You don't need to know the definition, but I'm just telling you some extra stuff. Okay? So now your job is to do A, B, C, and D. Yeah, this is example 15. Try it 15, sorry. So shall I do the first one for you first? Then you do the rest of the three yourself? Then we see whether Umar and Harif get scared or not. Because we learned a lot already, right? Then we show them what this is like, okay? Part A times I. So we've got 3, negative 4, 2, and 5 multiplied by 1, 0, 0, 1. Okay, what goes in my first row, first column? 3 times 1 plus 2 times 0. Okay. Next, first row, second column, what do we have? Wrong. 3 times 0. Okay, 3 times 0 plus 2 times 1. Okay, good. Second row, first column. Negative 4. Wrong. Times 1. Harif, don't bother lah. You were not here, I don't think you can get it on. No, not negative 4 already. 5 times 0. Okay, on the last element. Negative 4 times 0 plus 5 times 1. Okay, work it out, get the answer. Okay, so do it by yourself, part B, C, and D. Then we leave the two of them to wonder what's happening. For part A, 3, 2, negative 4, 5. Does it look familiar? Yes, where do we see it? Yeah, this is the same matrix, right? Apparently, when I take a matrix multiplied by the identity matrix known as I, it looks like this, it looks like this, and this. When you multiply by the identity matrix, you get back the same thing. Have we learned, are we familiar with something in primary school maths? Something times something, you get back the same something? You multiply by 1, right? 6 times 1, you get 6. 10 times 1, you get 10. Here we get A times I. You get A again. It is the identity matrix. Okay, let's take a look at B. Answer the same again. Do you all convince yourself already? I times A. Okay, so 1, 0, 0, 1, 3, 2, negative 4, 5. So 1 times 3 plus 0 times 4. 1 times 2 plus 0 times 5. 0 times 3 plus 1 times negative 4. Oops, there's a negative over here. Then we've got 0 times 2 plus 1 times 5. And here I get 3, 2, negative 4, and 5. 3, 2, negative 4, 5. Are they the same? Yeah, same again. So there is something very unique about this identity matrix. As long as I have it in this form, all zeros. Look at the part in the bottom. All of them are filled with zeros, but there is a diagonal 1. You will get back the same answer when you multiply it with another matrix. Okay, it is our it is similar to our value 1 when we multiply by 1. Okay? So let's take a look at part C. Hey Junior, you taught them already? So they know already, is it? Part C, B times C. So write it down. 4, 7, -1, -5, 6, -9. 0, 0, 0, 0. Can multiply? Can or cannot? Only Shufi, my only student? Cannot, So this one NA. Because 2 by 3, 2 by 2. These two are different. So cannot multiply. Okay, next we have matrix C times matrix B. 0, 0, 0, 0. 4, 7, -1. -5, 6, -9. So can or cannot? Let's write down the order. 2 by 2, 2 by 3. So can or not? Can. So multiply. Huh? All 0 So like that. Then how? What is the... you know that 0 times anything is 0, right? So should I bother writing everything out? Should I bother writing all the multiplication out? I know they are all zeros, So what is the order? Order. 2 by 3. It is going to be 2 rows, 3 columns. Where did I get it from? Here. It disappears. Like I told you, the information about the mobile phones, they disappear, right? The ones that are the same will disappear. So it will be 2 rows by 3. 0, 0, 0, 0, 0, 0. Okay? And I shouldn't say 0. I should say null matrix. A multiplied by the null matrix, and the null matrix multiplied by A, you will get back the same null matrix, which is a 0 matrix. A times identity matrix is the same as identity matrix times A, which is the same as A. In general, A times B is different from B times A. Sometimes it does not even work. It is not even applicable. And final point, since there is matrix multiplication, should there be matrix division? No, in this case we don't have matrix division. Not defined. You will never get a question on matrix division. So no matter what you do, when you think of dividing by matrix, right, stop yourself. You are wrong. Okay? What do you mean? That means you try to take, for example, matrix A divided by matrix B. There's no such thing. Okay, so the next part is the application of matrix multiplication. Let's look at example number 6. 12 minutes, we will finish example 16 and do try it 16. After this, we finish matrices already. So we've got matrix A, number of coins in wallet 1 and wallet number 2. So you see, here they write down the headings. And in matrix B, they show the mass of each type of coin. What is similar in these two matrices? Type of coin, these are similar, these are the same. And I would like you to write down, at this side, this will be known as the mass. They didn't write down the information, so please write it down. Mass. Very important in helping you identify what the final matrix is about. Okay, so find matrix A times matrix B. Okay, so matrix A times matrix B, we can do them, right? Because this is 2 by 3, this is 3 by 1. My resulting matrix will be 2 by 1. So we are expecting something here and something here. Okay, so do the multiplication as per normal. You get, this is order 2 by 1. Question. Now you can all do this part, except maybe Umar and Harif lah. You can all do it, right? But do you know what these numbers mean? Okay, that is where we need to go back to our headers. Okay, let me choose another color for bad idea. And okay. Okay. Now in your final matrix, I want you to put down the headers according to this, according to the highlighted ones. What goes where? Which one has disappeared? Green, purple, or light purple? Which one disappear? Green will disappear because they are common. So now you have to decide where to put the wallet, where to put the mass. Okay, so in my final matrix, what should be in these two sides? Mass or wallet? This side. Wallet. Specifically, wallet 1, wallet 2. Then what about this side? Mass. Okay, can you see how to transfer the header when you multiply by matrix, by matrices? So now, see, part B. Explain what a matrix represents. I told you it will come out. They always end off like this. Explain what it represents. Then you have the answer already. It is like in a table form. The answer is here already. The first 36.9, this must this 36.9 must represent the mass in wallet 1. Then the 50.58 must represent the mass in wallet 2. And how do you write it in words? We said that the product represents the total mass of coins in each wallet, respectively. Okay? Does it make sense to you? Then you get to try it 16. Okay, so if you were to transfer the headers, this is what you should get. Because Q, the matrix Q represents the marks. And in matrix P, we've got the 2 persons as well as the 3 sections. So Ty and Doris and the marks. So the matrix must represent the total marks obtained by the 2 of them respectively. Straightforward.